Okay, so how do we deal with what I would refer to as an HQ? In this particular example, we're just asked to factorise this quadratic expression. Clearly, it's not an EQ because we don't have a unitary x squared term. We've got a number in front of it other than 1. There are two main ways of doing this. One way that I learnt when I was at school, and one way that I learnt once I became a teacher, and I far prefer in most cases. I will show you both ways, and I will show you a little extra tip that you can use if you get really stuck. The way I was taught to do it was to think about FOIL in reverse. So we know that if we have something times x and a number, something times x and a number, that when we expand, our two first things that need to give us our 14x squared. So I was taught to think about factors of 14. Obviously, the x has to come with it. And so we could have something like 14 and 1 or 7 and 2. This one's not too hard. There aren't too many possibilities involved. Then, of course, we know that the last terms are going to be constants, and they are going to multiply to give -3. So in this scenario, we're going to need either -3 and +1 or +3 and -1. This is where it gets a little bit fiddly. We're not too bad here because we don't have too many different possibilities for our factors. But the way I was taught to do it was to remember that your middle term comes from your outer and your inner. So they give you your x term. So we need to get the correct combination of these factors so that we'll get a +19. Now, it's not too hard to see, particularly the way I've set it up, that if you get a 7x times 3, that will give you 21x, and a 2 times -1, that'll give you 21 minus 2, which will work, all right? Bearing in mind that the 7x needs to be multiplied by the +3, so they need to be in different brackets. You don't put them in the same bracket, and the 2x needs to be multiplied by a -1. We can check that we're right by expanding back out again and just making sure that that middle term is correct, as well, of course, as our first and last terms. Now, when I became a teacher, I learned a different method of doing this, which I far prefer in most cases. The method that I learned is the splitting the middle term method, where we divide that x term up in such a way that we are rigging it so that it will be an excellent grouping situation, and we will be able to take out a common factor out of our first two terms, a common factor out of our last two terms, and we will get a common factor bracket coming out. Now, how do we divide up that middle term? Well, the miracle answer here is that you need to find two numbers that multiply to give AC and add to give B. If you find those two numbers, then it doesn't matter which order you write them in, it will work so that you will then be able to use grouping. So in this case, for example, what we want is two numbers that multiply to give -42, because 14 times -3 is -42, and we want to add to give +19. Now, just thinking about this for a minute, if we want to multiply two numbers and get a negative, we know that obviously one of them is going to be positive and one's going to be negative. Okay, that's the first thing we need to think about. So in essence, what we really are thinking of are factors of 42 that are 19 different in magnitude. Let me just say that again. Because one of them is positive and one of them is negative, we need them to be 19 apart in magnitude. Now, 21 and 2 will work in terms of being 19 different in magnitude. We need to get the correct one negative and the correct one positive so that they will add to give a +19. Pretty obviously, we need our +21 and our -2. Now, it does not matter whether we go 14x squared plus 2x, minus 2x plus our 21x minus 3 and do it that way, or I'm going to do it the other way over here as well, just to prove that it will work either way. So we could split it up and write it in the different order. So plus 21x minus 2x minus 3. I'll just show you both ways. Obviously, using our grouping method that we should know by now, we're going to take 2x out of here and we're left with 7x minus 1. We can take a 3 out of those last two terms there and we get 7x minus 1. Lo and behold, as expected, as we rigged it, we have a common factor bracket of 7x minus 1, and in our second bracket, we're going to get 2x plus 3. Doing it this way, obviously you can take out, your next couple of lines will be different, but your answer will be the same. Here you can take out a 7x, so we're left with 2x plus 3. Be careful here, we want to end up with the same bracket, so if we take out a minus 1, that will take care of that very nicely, and we can have our 2x plus 3. You don't have to write the 1 here, but I find it helps a lot of students to do that. Every way, we've ended up with the same answer. Remember, multiplication is commutative. It doesn't matter what order you do it in, okay? Okay, so we've talked about several different ways of factorising this HQ, as I would term it. What if you're not having a lot of success with either of those methods? I'm about to do a video where I'm going to teach you a foolproof way to find those magical two numbers to divide up that middle term. However, there is yet another way of doing it. What you could do is you could imagine, even if you're just being asked to factorise an expression, you could imagine that you have this as a quadratic equation to solve. Now, we have a quadratic formula that will give us the answers here. So A is 14, B is 19, and C is -3. We know, according to our quadratic formula, that the solutions are given by -b plus or minus square root b squared minus 4ac all over 2a. So we're going to get -19 plus or minus square root of 19 squared, so 361, minus 4 times 3 times 14, so plus 12 lots of 14, all over 28. So this inside our square root sign is going to be 529. Square root of 529 is 23. Oops, don't forget our divided by 28. So our first answer is going to be 4 on 28, and our second answer is going to be -42 on 28. The first one simplifies down to the fraction 1/7. The second one simplifies to -3 on 2. Now, just like we did with an EQ in a previous video, what you can do from here is you can make your factors and use your null factor law in reverse. So what we're saying here is that x equals a 7th, which means that 7x equals 1, so 7x minus 1 is 0, or x equals -3 on 2, so 2x is -3, so 2x plus 3 equals 0. So here are your two factors, so we could go using that information to 7x minus 1, 2x plus 3, just checking that we haven't missed any common factor, which we haven't. Everything's all good there. 7x times 2x is our 14x squared, etc. Okay, so I'm about to teach you now one final method where you absolutely cannot go wrong. Hopefully you don't need to use this method too often. However, it is very handy to have for those difficult situations where you can't factorise it using the sort of old-fashioned way that I learnt when I was in school, and nor are you having much success coming up with splitting that middle term. All right, so that will be in our next video, so watch out for that one.